Okay, so this first one, you see how they use the limit for the derivative? They do not use the shortcut. So so you have one question like this where you have to do it the long way. But after that, I'm not going to make you do it. So 2, 3, 4, you just find a derivative any way you want. Okay. Um, Here actually tells you to use a product rule. Here tells you to use quotient, but the rest you just do it. Do whatever method you want. Okay. Let's see, but about 90, but the entire test is just about derivatives. So you'll have the basic power rule all over the place, product rule, chain, quotient, etc. So let's do number one, because I think that one might be one of the harder ones. Let's see if I should turn the light on here. Okay. Now, exam 2 review. So number one says use the formula for the limit as h approaches 0 of f of x plus h minus f of x plus h. Forgot the plus. Over h. Okay. So they give you a g, but who cares? We'll call it f just for consistency, since they were not consistent in the question, but who cares? Okay. All right, so here's f. So let's find f of x plus h in order to use the formula. So it helps to do it in steps. So if they give you the original, find the plus h version, which means you plug in x plus h everywhere that you have an x. I'm going to put parentheses to show that I plugged it in, not that it does anything, right? Oops, all right, so now we have f and we have fx plus h. So now I just put it all together. So the formula wants us to do this here. To put this guy first, and then subtract the original, divide by h. So just setting this up here will give you the majority of the points, right? Because this is going to be what? Let's do it down here. It's going to be kind of messy. So this fraction is on top. So we get x plus h over x plus h plus 5 minus the original x plus h, I'm sorry, x over x plus 5 divided by h. So it doesn't look very pretty, right? But doing this at least shows me you understand what they're asking. And if you get bogged down by algebra, at least you're mostly good, right? So here we got to combine the fractions and then divide by h. Stuff should cancel, and then the h's will cancel. But what is the LCD of these two fractions up here? Because you're going to need it, right? First question, is this prime? Can I factor anything from x plus h plus 5? This here?
Wouldn't it be 5?
Can you factor 5 from all three?
Oh, no. Okay, now I got your answer. I mean, your question.
All right, so it's prime, right? The bottom. Do you agree?
Yeah.
And this one's also prime. So if two denominators are prime, then the only LCD will be the product of those two. It's always going to be that way. If they're not prime, you factor and then you put the pieces that belong here.
Oh,
Okay. So this needs an x plus 5, right? This needs an x plus 5 plus h, or whatever, this thing. So they're not pretty fractions, but the idea is not complicated. Just looks nasty. So multiply this guy by the missing part in order to introduce the LCD, right? We've done this a bunch of times back in the day. Okay. This guy needs the other piece, so multiply by x plus h plus 5. Okay. All right, so just multiply it out, and then we can combine. So the top will be a FOIL, right? A distribution, so x times both these parts, h times both of them. So I'm going to get x squared plus 5x. If I multiply the x on both, and then multiply the h on both, you get plus xh plus 5h minus, right? You agree with these four terms?
yes.
Now multiply the x on all this, you'll get here. So down here, I'm just going to put LCD, right? And that's what that is, because we got it in there now. Is that cool with you? Is that fine?
Mm-hmm.
So multiply the x on each of these terms, you'll get x squared plus xh plus 5h. So,
X.
oh yes, thank you. 5xx. Yes,
The last one. Yeah.
just double checking. All right, so then just subtract them. Notice how there's a minus in front of the whole thing, so all of them will become minus. So we will get x squared plus 5x plus xh plus 5h minus all this stuff. Bunch of garbage.
Screw over.
Screw your paper up.
Thank you. Over the LCD, I'll go ahead and write it this time. So I'm not too weird here. Okay. So notice how everything's going to cancel, right? Don't forget that there's an H down here. So since I forgot, I'm going to tack it on like this because it looks a little prettier. Because this is the same, right?
Mm-hmm.
This whole time I've been working on the top of this complex fraction. But if I go ahead and divide by h, that's the same as multiplying by 1 over h. So I'm going to do this at the very end. So I'm just going to keep working on this. So the x squares are gone. xh is gone. 5h is not gone. 5x is gone. This one's fine. 5h is fine. Right? So we're left with 5h over the LCD that we introduced. X plus h. So then the h's cancel, right?
Mm-hmm.
So now I can take the limit. Technically, I should have written the limit all the way down. I just forgot. but also there's not much space and I don't want to jam everything close together. But you see how it's supposed to be there, right? So at the very end, you decide to take the limit. When I take the limit, what's left over? And that's it. Do you see why that's squared? Right. If h is 0, this becomes x plus 5, right? X plus 5 times x plus 5. There's 2 of them.
Okay.
So that's it. You take the limit, and you're done. So this is the derivative.
Oh,
That's f prime.
With a do we have to simplify it all the way to the end like that, or? we can
Yeah.
do it?
Yeah, you have to.
Okay.
That's the only way you can take the limit, because you can't take the limit until you cancel this h. The once the h is gone, you're good.
Mhm.
But in order to do so, you have to combine two fractions, cancel terms, and then you can do it. So I'm only gonna make you do that once because that's annoying. Any questions on any of those steps?
Where did the 1 over h come from again?
Oh, it's part of the formula, right? You divide by h.
Oh, okay, so you just removed it.
So yeah, I just said, you know what? Let's just write to the side as 1 over h. That's the same.
Then we could just double check our work knowing all the shortcuts now, right?
You could use your quotient rule and check if it's the same. That's true. It's a good idea. But I'm looking for this work for credit on number 1. Not the answer, but you are allowed to check your stuff. You guys have any other questions on this one?
No, that's fine.
All right, let's look at number 2. Number 2 is find the slope of the curve at the given point. So they give us a point right there, right? So all we got to do is take a derivative once and then plug in the number. That's it. Nothing else to do. So I'll leave that one for you. Number 3, this one's a little more difficult. Let's do 3. Let me write the question down. Find the equation of the tangent line. Okay. On the curve at the given point. All right. So y is equal to x squared plus 3. And then they give us a point 4, 19. So they want us to find some line, right? Which is mx plus b. We should probably write down the formula, point slope formula. This one will be easier to use than this one. Okay. Just remember that the m is given by the derivative. So step 1, take a derivative and plug in x equals 4 to find the slope. Okay, so not too bad, right? What is the first derivative?
Okay.
2x.
I'm sorry, 2x, yeah. 2x.
2x, right? So plug in the 4, and we get this, right? So m is 8. So now we can use this formula. So step 2, use the point slope formula. Since you now have m, x, and y, right? Because that was given to us, the x and y. So y minus y1 is equal to, well, actually, let me write down everything first. Let me write the formula right here. So m is 8, 419 is the point. So plug in 19, plug in the slope, plug in the x. Solve for y and you're done. So what do we get here? That would be-
8x minus 13.
Yeah. You said 13?
Yes.
Okay. And that's it. This is the equation of the tangent line. Now, does this make more sense now that we're doing it a second or third time?
Just what you put over here, use the point slope formula, what?
Since you now have
Since you now
the
have-
m, x, and y, which are these right here. I'll make it prettier, I guess. You have a point and a slope.
How much time are we gonna have on the test?
I'll have to look at it. I'll let you know.
Okay.
I'll let you know after.
All right, thank you.
Okay, so 2, 3, 4 are all the same thing. So I'll leave these to you.
Is the Desmos calculator, yeah, gonna be used or a lot to be used?
If you need it, I can put it in there, but you shouldn't. There's no graphing in this test.
Is there any related
Yeah,
rates
but-
problems?
There'll be a 1 or 2. Yeah, there'll be a couple.
Can you go back to the example 3 really quick?
Mhm.
Please.
Yeah, on paper, right? Or on the.
Yes, that one.
Okay.
Thank you.
Just one moment. So let's move on to number 5. That one's different. Solve the problem. All right. Yeah, those stupid instructions. Let me erase that. Find the points. Where the graph of the function has horizontal tangents. So basically that means whenever you have a peak or a valley, right? So the way you find these is to make the derivative equal to 0 and solve for x. That's it. So here is the function they gave us. Where is it? F of x is equal to x cubed minus 21x. So step 1, find f prime, right? So the derivative will be the subpower rule. So bring down the 3, subtract 1, and that just becomes a 21. Step 2, set the derivative f prime equal to 0. So f prime of x equal to 3x squared minus 21 equal to 0. So solve for x.
Is that a 3 cubed minus 21 next?
3x squared.
3 2i?
21.
21, sorry.
Yeah, I'll write it again for you.
I wasn't paying attention.
It's okay. All right. So set this equal to 0, solve for x. So factor 3 out, that gives us this, right? Divide by 3, well, it's gone. Add 7 over. Square root both sides, and that would give us a plus or minus. So x is equal to plus or minus square root of 7. Because we square rooted both sides, we have to tack on that plus or minus. So let's see. It said find the points. Let me check the answer. If they want the coordinate or just the x value. I think it's just the x, but yeah, they do want the coordinate. Okay. So step 3. That means we have an extra step. Plug in x equals square root 7 and x equals negative square root 7 to find their corresponding y's. Y values, I guess. Into f of x, of course, right? Not the derivative. So you do f of square root 7, which would be square root 7 cubed minus 21 times square root 7. Then you do it again for negative square root 7, which will give us negative square root 7 cubed minus 21 square root 7. So that will be, so square root 7 times itself 3 times will be what? This, right? 7 minus 21, that would be 14, right? This will be the same, except it is negative. Negative 7 plus 21, that would be positive. There we go. Okay, so the solution will be square root 7, comma, negative 14 square root 7, and negative square root 7, comma, 14 square root 7. So once you solve for the x's, you got to plug them in the original to find the points. Any questions on number 5?
I'm sorry, I think I got lost. You put a 3x squared minus 21 equals to 0, right? Now you factor 3x squared minus 7.
Yeah, so factor the 3 out and you see where the x squared and 7 came from, right?
Yes. The
Okay,
7 is
so-
because the factor of 21.
Right.
So the 3, you eliminate, what is the 3?
Oh,
the three
okay.
is-
This is what happens. You divide by 3 both sides.
Oh, okay.
Yeah, whenever it's
Oh.
equal to 0, the constant will do
Yeah.
nothing.
Okay. Yeah, I was looking at the 3. Okay,
The rest makes sense?
yes.
Can you explain how it became like 7 square root of 7 with the to the cube?
Oh, sure. Yeah. So square root 7 cubed, right, means square root 7 times square root 7 times square root 7. This right here is a square, right?
Mhm.
So that's 7. When you square a root, you get the 7. So you get whatever's inside. But this one just stays there. So you have 7 times this leftover.
Oh, okay. Thank you.
That's what happened here as well. It's just that it was a negative. Okay, excuse me. And give me one moment. You guys have any other questions? All right. Let's look at the next questions here. Number 6 is the same deal. Let me show you. The only difference is it says that has a slope of 2. So it says find the equation of the tangent to the curve. So this actually, no, it'll be a combination of interesting. So they're giving you the slope, but not the x value. Like over here, they give you the x and y, right? For 1, 2, 3, 4. See that?
Can you just set the derivative equal to 2?
Yeah, that's what you're gonna have to do. So you take the derivative and set equal to 2. You solve for x, and then you have the x, which you then plug in here to get the y. So you'll need, it'll be a kind of a combination of number 2, 3, 4 type of question with a little bit of 5 in there. Let's see. Let me see, what should we do next? There will not, oh, actually, there'll only be one Newton question, so probably save that for next time. We'll see how it goes. Let's move on to the product rule. Here, check these out here. So 7 and 8 are technically product rules, right? 7, they force you to do it. 8, they don't, they just tell you to find it. But honestly, in 8, you don't really have a choice unless you force a quotient rule. But I don't know what kind of weird person would do that, but you could. Most people prefer to force a quotient into a product, not the other way around. But here you see how you could multiply it all out and then find derivative term by term. So you could do that here. But they're gonna make you do the product rule. Okay. You want to do 7 or 8? What do you guys think? What seems harder to you?
Both.
They both seem hard.
7 seems harder for sure.
7.
Yeah, 7.
You can do both, it's fine. But yeah, let's do 7 first. So find y prime using the product rule. Okay. X squared, 2x squared, 2x cubed minus x squared plus 4, x squared plus minus 2x plus 2. Okay, we're good.
How many questions are on the thing total? I missed that bit.
The actual test or this review?
Both.
The review is 24.
Okay.
I'll let you know on the other one once I look at it. Remind me
Okay.
after we finish the review.
Okay. Thanks.
Okay. Oh yeah. So we're doing this guy here, product rule. I'm gonna write the product rule up here. We have a product of two functions, f times g. The derivative will be f prime g plus g prime f. So the derivative, so I'm gonna label this f and g. Y prime will be derivative of this guy. So I'm gonna show the steps, but not actually do it just yet. So I'm gonna put a quote on there, this derivative times the second part plus the first part times the derivative of the second part. Right? So what is this derivative here gonna be?
2x minus 2.
Yeah, 2x minus 2. That's right. Times the second part, so that stays the same. This stays the same. What is this derivative here?
6x minus 2x.
Yeah, there we go.
I forgot the square and the 6x. 6x
Thanks.
squared minus 2x.
Yeah, sorry, my phone started ringing. That's weird. Sorry, anyway. Yeah, that's good. So we brought the 3 down, times 2, yes. So now we just gotta do a bunch of algebra. All right, so this multiply this times everything, and then this guy times everything. So we're gonna get 4x to the 4th minus 2x cubed plus 8x minus, now multiply everything by negative 2, 4x cubed plus 2x squared minus 8. Now multiply everything by, or we can do it backwards if you like. This times this one. This times all those. So let's do the 6x squared first. So that'll be 6x to the 4th minus 12x cubed plus 12x squared. Running out of space. Minus 2x cubed plus 4x cubed minus 4x. Yeah. Although after I did all this, I wonder if they even multiplied it.
I think you got the, if I'm mistaken,
Okay.
the second to last 4 should be squares if you.
This one?
No, the next one.
Here.
Yes.
Yes, you're right. Let me double check. That was
Give me
the
a 4 over
2,
there.
right? Negative 2 plus 4. Oh, yeah, I see what you're saying. So that should be a 2. Yeah, I don't know why I put a 3 there. And then the last one, that one's good. Okay. So combine all this nonsense. So 4th power is only 2 of them. 4 and 4, or 4 and 6 is going to be 10. So let me get rid of my 4th powers. Cubes, so minus 2 minus 4 minus 12 is minus 18 minus 2 more 20. There's all the cubes. Squares. 2 plus 12 plus 4 is what, 16? Right? Or did I
I think
mess
it's
that up?
18.
Yes.
18? Oh, thank you. Okay. Now, x's. 8 minus 4 is only 2, right? And then the constant. Finally. Looks like answer B. Yeah, we got it. Any questions on 7? I know I got kind of, I guess, algebra heavy, but
I have one quick question, but the product rule, the derivative versus the one that has the g g of x squared at the bottom. What?
oh,
which
the
one's that
quotient?
one?
That's
Oh,
called
the quotient rule. Oh,
Yeah. So whenever you have a fraction, you use the quotient. You guys have any other questions on number 7?
No, sir.
No, let's go to 8.
Let's do 8.
I hope you don't mind.
Nope.
I miss my.
Right, this one z equals 8x squared times ex.
Are we gonna use the product rule as well?
Yeah, we're gonna use it because there's 8x squared times EX, so that's a product, right? One moment, guys, sorry. All right. So F, we'll call the first one. G of X is just the second piece.
Is it equal to Z?
Yeah.
Okay.
So Z prime is equal to the derivative of the first one times the second plus the first one times the derivative of the second one. So this derivative is going to be 16x EX plus derivative of EX stays the same, so we're just going to have this. You could factor X and 8 and an e to the x, right? Leaving you with, 2 plus x, if you wanted to.
Is that one of the acceptable answers, or let me just leave it as 16x e to the x plus 8x squared?
They left it this way, so you wouldn't have to factor. I just did it because sometimes they do. But for me, yeah, I'll take either one. It's just that if you want to look, if you look at the answer choices and it's not there, it might be because they took a step further. Just trust your work if that happens to you.
Professor, have you graded the first test?
Yeah.
Right? Oh,
Mhm. Yeah, whatever grade is in there is the legit grade.
Wow, wow, wow.
Let's see here. All right, so 9, 10 are quotient rules. Let's see here. Yeah. So we'll have to do quotient and add fractions.
I'm sorry, before you move on,
Mhm.
how did it? Never mind, I lost my question. Forget it, I'll go back to it.
Oh, it's okay. Just let me know when you remember.
Okay.
Okay. Write the quotient rule up here. If you take a derivative, okay, here it is, the formula. I always look it up because I forget which one goes first, because the minus is important. The product rule, since there's a plus in the middle, it doesn't matter which one goes first. So if you mix it up, who cares? But quotient, it does matter. So I always double check. All right. So number 9. G of x is equal to x squared plus 5 over x squared plus 6x. All right.
Is that a squared under the denominator?
Yeah, x squared plus 6x.
In the quotient rule, I kind of forgot.
Oh, in here, yeah. That should be g squared.
Okay.
Okay. So they called it g, but since our formula has a g in there already, I'm going to change it to y. Who cares? So f is this guy. G is this bottom part. You could also do the derivatives ahead of time. Some people like to do that and stay neat, but it doesn't really matter what you do. As long as you follow the math rules, it'd be cool. Okay. We will also need a g squared, so I guess I could do that now, but that's fine. They left it square in the answer choices, so we won't have to. So the derivative of this y function will be g times f prime minus f times g prime. Okay. G is here it is. All right, so there's the using the formula. Now let's go ahead and plug it all in. So this will be x squared plus 6x times 2x minus x squared plus 5 times 2x plus 6 over x squared plus 6x squared. Okay, make sure to miss anything. That looks good. All right, so multiply this out. Multiply these guys here. So you'll get 2x cubed plus 12x squared minus, put a bracket here because everything will be, we'll have a minus on it. So 2x cubed plus 6x squared plus 10x plus 30. Okay. 2x cubed plus 12x squared. Distribute that minus, so everything just swaps signs. Oh, crap. Okay. Combine like terms. These cubes will be gone, right?
Mhm.
12 minus 6,
Square.
10x by itself, minus 30. All right. And that should be it. Huh. Top part's good.
I had like a different,
Yeah, did you see a mistake?
is it 6x squared plus 10x plus 30 over x squared plus 6x squared.
Yeah, they have an extra x squared here. Is that what you get?
No.
Oh. Well, the top part's good. They just have an extra term right here.
Did they maybe extract an x out of that bottom part?
Yeah, they did. Yeah, they did. They factored the inside. Now that I look at it. Yeah, let's check it out. So they pull out an x from each term, but it comes out squared. I see. That's kind of unnecessary, but oh well. Weird.
Wait, if it's they pull out an x square, how does it still the second half a square as well?
Well, you pull out an x from these two, but it comes out as a square because of this.
Okay, gotcha.
All right. Technically, what you do on the bottom, let's just go ahead and show it.
Oh, I see what you did. Yeah, I see.
So what they did, just to be weird, I guess. So you can factor an x out, right? This whole thing is squared though. So you get this with one extra step. See what I mean? You apply the power to
Yeah,
both.
yeah, I see.
Yeah, when I saw their answer, I was like, the hell did I miss? But I didn't notice. I didn't notice that this had been factored already. I thought it was the same still. I'll leave 10 for you.
Could I see your paper really quickly? I'm
Yeah.
sorry.
Yeah, you guys have any questions on this?
Can we take like a quick 5-minute break?
Yeah, yes, we could do that. It's 10 o'clock. Let's come back at 10. At 10:15. I didn't realize it's been an hour. All right. So they give us this function. Q is equal to the square root of 17r minus r to the fifth. So the derivative of q. Well, first we should rewrite the q. So that's the same as saying 17r minus r to the fifth to the 1/2, right?
Mhm.
So do it that way because this is my outer function. And my inner one is this r stuff. So do the power rule. So you bring down the 1/2, leave everything the same, subtract 1, and then multiply by the derivative of the inside. Derivative of 17r, derivative r to the fifth. So at this point, the derivative is done. You just need to do some algebra. So this will be a negative 1/2. So this will become a negative power to bring this whole piece to the bottom. So we're going to get 1/2 times this part. This stays on top. And then this half can go to the bottom as well. So we get 17 minus 5r to the fourth over 2 times square root of 17r minus r to the fifth. That is as pretty as it's going to get.
Now, how many steps can we skip So like if we went from like where you have the Q prime and immediately went there because of the negative 1/2 to the 1/2 square root. If we just
If you skip which step, this
pretty
one.
much went from Q prime to the answer minus like writing it out. That to the left of where your pin is right now.
So you're saying from here to here.
Yeah.
That might be okay. Just be careful. Don't skip too much. That would be okay though.
Can you explain me real quick how did you get the from second from last to the last the
Here
num-
to here.
yes the 2 squared 17r minus r.
So the half power means square root, right? That's the same.
Yes, yes. Mhm.
The 1/2, that's the same as just putting the half right here is weird. That's the same as having the half out here instead.
I see.
So having the half in front, it might be better to just leave it like this so it's not confusing. Because this piece is here. This piece is up top. This piece went to the bottom, and then this is to the side, so you can bring that in here instead. I think that's better.
Would it be easier to visualize, like to see it as the 1/, either 17r minus r5 to the 1/2, or 1/, square root of 17r minus over 2 square root of 17r?
I mean, it's up to you
So
guys.
visualize it.
Whatever makes more sense to you, I think that's fine. You can think of it as the fraction flipping and doing a product. You can think of it as just 3 separate terms. It's up to you.
I have a question. What if you have like, for example, like a 1/2 x, or like an r, like a 1/2 r, and then the rest of it? Where would you put the r?
If I had a 1/2 r here,
Yes. Just like for the sake of just saying like,
just for
just know
fun. Well, it would the r would be on top. Technically, if you had a 1/2 r, that's the same as saying r/2.
Okay, gotcha.
So like if you had an r like this, then technically it would be that. Right.
I gotcha.
Okay. So any questions on number 12 with the chain rule?
No, sir.
Okay, 13 is going to be a product rule that has chain rules attached to it. So y equals x plus 1 squared times x squared plus 1 to the negative 3. Okay. All right, so here's my f and g. So, yeah, so we'll do the product rule, but during the product rule, we will have chains. So let's go ahead and show the product rule step. So we have x plus 1 squared. So take derivative of this guy first. And then times the second plus the derivative of this guy times the first. All right. So this derivative would be a chain rule. So bring down the 2. Derivative of the inside is just the 1, right? You see that? So it doesn't make a difference. So the derivative, the chain rule is technically always happening. It's just most of the time it's a 1. So you don't even think about it. Over here, well, this inside is x squared, so it's not going to be just a 1. So you're going to bring down the -3, subtract 1, so it becomes a -4 times the derivative of the inside, which would become a 2x. And this piece is just chilling here. Okay. So we got 2 negative powers. So we have to take those to the bottom, right? All right, so this would become, distribute the 2, and it'd be 2x plus 2 over x squared plus 1 cubed. -3 times 2x is a -6x, right? Times x plus 1 squared. So combine these two terms and put that up right next to it. The negative will have to go to the bottom, which will give us an x squared plus 1 to the 4th.
That x squared that's alone, how did you get that?
Yes.
That one?
Here?
No, the one you pointed next to it.
This
The
one?
x- not the x squared, the 2x, sorry, yes. that
Oh,
one.
okay, okay. Yeah, so the chain rule says, right? So I'm doing this derivative right here. That's what this is. So you bring down the -3 and you subtract 1, right? That part makes sense.
Mhm.
And then times the derivative of the inside, which is 2x, right? That's where this came from. So when you do this derivative here, you have to do a chain rule. Does that make sense?
I think so.
Do you remember the chain
Maybe
rule?
can you write the chain rule formula real quick?
Yeah, so let's do it. So if you have a function, let's call it y, where the function has another function inside it, then the derivative would be the derivative of the outside function and leaving the inside alone times the derivative of whatever was in there. Okay. So let's just go through some blank page real quick. So if you had something like square root of, actually let's do something easier. X cubed plus 7 squared, right? The derivative would be bring the 2 down. That's the outside. Subtract 1 and then multiply by the derivative of the inside. It'll always be this way. So this is f, this is f prime. So this is my g inside. This is my f, the outer function. Okay. That's what the chain rule is saying here. So you have some outer function and an inner function. So it's a composition of functions. So over here, we have a -3 power as the outside, and x squared plus 1 as the inside. So the derivative of the inside is 2x. Derivative of the outside is this.
Oh. Yes.
Is it fair to say that you only multiply the function of the outside to the derivative of the inside? That's what it is, right?
Yeah, your derivative of the inside times the derivative of the outside.
So you leave the middle alone.
Yeah, you don't mess with this. That's done over here.
Okay.
Yeah. And if you have multiple inner parts, then you would have maybe 3 chains instead of just 1 or 2. You could have 2. Depending on how composed the function is, like if it's sine, like for example, you had a sine of a square root like of 2x squared or something, that would be 3 functions. So the chain rule would happen 3 times. So then that type of stuff could happen. All right, so LCD and we're done, right? This is a third power and that's a fourth power. So I need to multiply the top and bottom by this guy. I'm going to skip an LCD step. Hope that's okay. I guess we'll have to review some more on Wednesday. Didn't realize how long this was. Okay, over x squared plus 1 to the fourth. Any questions on 13?
In the test, for example, like that question, the answer would be exactly that, or would it be like, would you still have to distribute the x squared plus 1 with the 2x plus 2?
In this case, what they did was factor these two. You see how there's an x squared plus 1 in common?
Okay.
They did that and that was it. But pretty much the same. They did one extra step. But they didn't FOIL everything out like you said.
Gotcha.
Okay. Let's see here. I think we might have time for 24. I'm skipping to the end because it's Newton's method.
Thank you.
So basically, this method is a good method to solve the equation. Here, let me.
Your camera is blurry.
Sorry about that.
Right, there you go. Thanks.
Let me find the formula. So Newton's method basically solves for zeros of a function. And you know what I mean by zeros, right?
You basically equal out to 0, like to solve for x or something?
Yeah, like back in college algebra, you remember how we had the
Yeah,
zeros of a function?
right.
So Newton's method uses derivatives, and in computers we use this all the time to approximate a zero. And your calculator might automatically do it as well when you try to find it using software. Instead of finding an exact answer, you find an approximate answer. So you would code this on a computer, or you would use software that already has it in there. So basically, the formula for Newton's method is this guy. So x to the n plus 1 is equal to xn minus f of xn over the derivative at xn. So they have to give you the first one. Another way people like to think of it is this way. So they say, you know what, I need to find the first one, x1, which means I need x0, and then I need the function at x0, meaning the initial x value that they give you. So they kind of give you like an estimate, like, I think the zero is somewhere around here. So here's like a kind of like a seed for like a number generator, what's it called? Random number generator. So this would be like your seed. So you plug it in there, you do your math, and you get x1. And then you plug it again, you do x1, plug it in here, and you get x2, right? So x2 would be x1 minus f of x1 over the derivative at x1. So you see how this is repeats forever, right?
Right.
So this is called an iterative method. So that this is something you would program because you're not going to do this a million times, right? That's stupid.
Right.
So Newton's method will approximate a zero using this general formula. So the exam will make you do it twice. That's it, because it wouldn't make sense to make you do more than that. So here's the function, x to the third plus 5x plus 2. So let me go write it over here. That looks messy. They give us the x0 of -1. So I need the derivative, right? Which will be this. Then I need the function at x0, which would be -1 cubed plus 5 times -1 plus 2. And I need the derivative at x1, or x0, sorry, which would be 3 times -1 squared plus 5. So this would be -1 minus 5 plus 2, which is, what is that? -4?
-4.
Yeah. And this guy would be what, 2? No, 8. 8. Sorry, I'm low on time. Forgive me if I'm going a little faster. So once you find these guys, you just plug it into the formula. So x1 is equal to x0, right? Minus the function at x0 over the derivative at x0, which will be -1 minus, and we got -4 first, over 8, right?
Mhm.
Right.
So minus would be -1 plus, what is that, 1/2? So -1/2. So we got x1. That's this. But the question says find x2. So x2 is equal to -1/2 minus f at -1/2 over the derivative at -1/2. So you have to find these guys. Since I'm out of space, I wanted to do it like this again, but I'm low on space now. So -1/2 minus, so plug in -1/2 to the original function. So that would give us, you know what, let me make some space here. Yeah, I'll just go ahead and turn the page. It's fine. F was x cubed plus 5x, right? Plus 2. Okay. So f of x2, sorry, x1 is going to be, it was -1/2 or positive? Negative.
-1.
Okay. So there's the function at that value. -1/2 cubed would be -1/8 minus 5/2 plus 2. What is that going to be? x1 here, that'll be negative half squared plus 5. So 3/4 plus 5. Okay. All right. What's all that fraction stuff going to be?
So minus
Times 4. This is 23/4, right? This one. I'm going to get my calculator because I'm getting lazy. Negative 1/8 minus 5/2 plus 2. This is negative 5/8. So the formula says that x2 is equal to x1 minus the function at x1 over the derivative at x1. So we will get negative half minus negative 5/8 over 23/4. So what is this going to be? Be 5/8 times 4 over 23.
$20.
Approximately negative 0.3913. So this iterative method goes on forever. The more times you do it, the more accuracy this gets. Eventually, the accuracy is so tiny, or the difference. Like once you do it like 1,000 times, doing it 10,000 almost shows like no difference. So there's a point somewhere where you'll get close enough. And if you were to program this numerical method, you would have to build in a tolerance to tell the code or the program when to stop. So you say, you know what, when I get close to, I don't know, 10,000s of whatever, right? You can choose your own tolerance. Anyway, but we'll talk about it some more next time. That's in a nutshell the Newton's method. I want to give you at least something so you can start the homework.
Can you share the formula real quick? So I can copy this?
Yeah, that's right here.
Thank you.
This one. So this is the general formula, and this is applying it to x1 and x2. All right, and we'll stop here. So we'll continue do a few more problems next time, and we'll do some homework questions, etc., and maybe some Newton's method on Wednesday.
When is the test?